Hey everybody, this is the video for Chapter 14 of Price Analysis, a fundamental approach to the study of commodity prices. In this chapter we're going to take a look at the ethanol market, and in particular how the ethanol market interacts with the market for corn to impact prices in both of those markets. And we can't talk about the ethanol and corn market without talking a little bit about regulations that have spurred this sector in the last 10 years. In 2005 and 2007, two key pieces of legislation were passed. The first was the Energy Policy Act of 2005, and the second was called the Energy Security and Independence Act of 2007. These two pieces of legislation created the Renewable Fuels Standard, and that Renewable Fuels Standard, otherwise known as the RFS, mandates quantities of ethanol that blenders of gasoline are required to blend into the retail gasoline supply. So in these early years they made projections for those mandated quantities really far out into the future, like all the way to 2020. But every year the EPA revisits those standards and adjusts them to meet what is realistic in the marketplace. They have to do this particularly because there are several categories of biodiesel. Particularly there's what's called conventional biodiesel, which is usually fulfilled through corn-based ethanol production, and there is what's called advanced biofuel. And renewable fuels are classified as conventional or advanced based on their percent in greenhouse gas emission reduction. So corn-based ethanol achieves 20% emission reduction according to life cycle analysis done by the EPA, while advanced biofuels have to be achieving greater than 50% reduction in greenhouse gas emissions, and biomass-based diesel, otherwise known as biodiesel, achieves about 50%, and cellulosic biofuel achieves greater than 60% reduction in greenhouse gas emissions. So that advanced biofuel category is the real stickler in why they have to revisit these mandated quantities every year. We found that the corn-based ethanol market really responded to these mandates and increased capacity significantly over a very short period of time. And that's because the technology to produce corn-based ethanol was very easy to replicate and well known, and people were able to just build out factories and start producing very quickly. The same is actually true for biomass-based diesel, but the economics have never really favored building out that much capacity for biomass-based diesel. Cellulosic biofuel is a whole nother beast though, because it's a process by which one would try to produce ethanol from cell walls of fibrous plants. So thinking about taking corn stalks or dried grasses such as switchgrass or miscanthus and converting those through some complicated chemical process into ethanol. And that process is possible. It's been done on a small scale, but no one has yet been able to create a production process that is economical to do at commercial capacity. So the RFS originally and continues to have optimistic projections about our ability to increase cellulosic biofuel production, but every year they've had to write down those mandated quantities compared to their optimistic hopes for those quantities. So unless a major breakthrough happens scientifically, then I think we could expect those quantities to get written down in the future as well. Alright, so here in Table 1 I've listed some recent RFS mandated volumes from 2014 through 2017, and the way that these things are usually written is they give a certain amount of mandated volume for cellulosic and biomass-based diesel, and then general advanced biofuel. And advanced biofuel can generally be met by either biomass-based diesel or cellulosic biofuel, or sugarcane-based ethanol, which is which has to be imported. And basically, if you take this total renewable fuel number, so they say we are going to ensure that we blend 18.8 billion gallons of renewable fuel into the retail fuel supply, and you subtract off 4 billion gallons of advanced requirement, you're going to get about 14 billion gallons of essentially a corn-based ethanol mandate. Because they say your total has to be 18.8, you have to make at least 4 of this very special kind, and the rest, the best way, the cheapest way to meet that requirement is with corn-based ethanol. So I mentioned that the EPA revisits these rules every year to determine what is feasible, and this is often a source of political consternation because you have farm groups on one hand who want to maintain RFS levels at high levels, and then you've got the oil refining industry who doesn't like to be faced with these mandates, and they want these quantities written down. And every year when the EPA is making these rules, it's kind of a guessing game or a political analysis about which of those two competing interests are going to prevail. So far it's been those in favor of keeping the RFS at basically the original mandated levels, aside from adjusting down the cellulosic requirement usually. So now that we've set that most of the biofuel requirements from the RFS is going to be met with corn-based ethanol, let's take a look at where this ethanol production happens. And the Renewable Fuels Association provides this map tool that allows you to see where every ethanol plant in the United States is located, and that I've copied that here in Figure 1. And you'll notice and probably not be surprised that most of the corn-based ethanol plants are located in what we would call the Corn Belt, where we produce most of the corn in the country. So that's really not that surprising. And it turns out that you can make ethanol, corn-based ethanol, by basically 2 different processes. The first is called dry grind ethanol production. And in this kind of process, the entire kernel of corn is ground into a meal, and then that meal is mixed with water to create a slurry. And once they have this slurry, you can add some enzymes that will convert the starches into a simple sugar. And then if you add ammonia and yeast, the yeast will ferment the slurry and convert it into ethanol and carbon dioxide. So once that's happened, the ethanol is dehydrated to 200 proof, and then a little gasoline is added because you could actually drink it like other alcohol if they didn't basically poison it with a little splash of gasoline. And so that's how you get ethanol. But in that process, there's a bunch of solids that are left over, and that is called stillage, and that can be dried and dehydrated, and it actually makes pretty good livestock feed because it's got a little bit of carbohydrate left. Most of the fat and the protein is left because that only the starch can get converted into alcohol. So it becomes a pretty good animal feed that you can use in a similar way as soybean meal because it's pretty high in protein. So since this stuff has to be dried, it's usually dried by natural gas fuel dryers, and natural gas turns out to be a significant cost in dry grind ethanol production for this reason. But it means that dry grind ethanol production is basically a co-product process. You go through this one production process and you get ethanol and DDGs, similar to how when you crush soybeans you get oil and meal. So you get 2 things that you can sell and get revenue from. So that process we just described as the dry grind process is what the vast majority of ethanol is produced with. The second kind is called wet grind ethanol production, and it's not nearly as common. But the way that works is that the whole kernels of corn are steeped in a combination of sulfuric acid and water, and that makes the kernel break apart into its components: the pericarp or the skin, the endosperm, which is where all the starch is, and the germ, which contains the oil. So basically you're pre-processing the corn and separating out the starchy part, and then you can just work with only the starchy part and convert that into oil. And then you have left the germ and the pericarp that you can do other things with. So grind it up and sell it directly as animal feed. But this production process turns out to be slightly more costly. So when we were building up capacity in ethanol production, it was primarily the dry grind process.